Concept 2, simplifying expressions with fractional exponents. So a fractional exponent, when the numerator is not 1, we're going to kind of evaluate the same way, except we're also going to have a power. Okay, so we're going to have a root, but we're also going to have an exponent. Okay, and that exponent can either be inside the root. All right, so this is my numerator is a 2. My exponent can either be inside the root, or it can be outside the root. Okay, we'll get the same answer, and you can evaluate it whichever way you want. Sometimes one is easier than the other, but it's not always the case. Okay, so if we look at these, let's just do both of them. Okay, so we have 3 third root of 8 to the second. So let's just do 8 to the second. 8 times 8 is going to be 64. And we have the third root of it. Okay? Now here we have our second power outside. So we have the third root of 8, and then we're going to raise it to the second. So here we're going to have the third root of 8, which is 2 times 2 times 2. Okay? So my root, right, my third root, oops, don't forget my second power. My third root is just going to be 2, because it's 2 times 2 times 2. So I'd have 2 to the second. The third root of 64, so what number times itself, and then itself again, is going to be 64. That's going to be 4, right? 4 times 4 is 16. Times 4 again is 64. Okay. The way you will do these, and I forgot to show you on a calculator last video, when you have a root, okay, a root other than square root, okay, the way you will do them, the way I usually do them, if I'm not sure, is I use this button right here, x to the y, or sometimes it'll be a caret. Okay, it'll just look like this. And if you're using a graphing calculator, that's what it'll look like. Okay, but if I have 64 and then I raise that, you're going to need to use parentheses to make sure your calculator does things in the right order. But you'll raise it up to the, and this is where we use our idea that a root is the same as a fractional exponent. So 64 up to the 1/3 power. And then that is equal to 4. Okay, so that's how you're going to do it on the calculator most of the time. If you have a graphing calculator or one that instead of having x to the y on it, you have the caret, it's just going to be 64, and then you press the caret, and then parentheses 1 divided by 3, and then enter. Okay, and that's how you can do a third root or a fifth root or whatever root you have. All right. So if we look at 625 to the 3/4 power, okay, that's going to be equal to, take my numerator, and I think I'm going to do this one with my numerator on the outside. So I'm going to take my 4th root, my denominator as my root, 625, and take that to the 3rd. Okay, so 625 raised to the 1/4 power is 5. So then I have 5 to the 3rd, which I know is equal to 125.
Sorry for the interruption. If you are leaving...
Okay, so we had 125 as our answer. All right, looking at another one, we have 32 to the 6/5. Pretty much whenever you get something like this where it's a pretty small number and you've got that big of a root, right? a fifth root, that's pretty big, it's going to be 2, right? 2 is going to be your base, or at least a factor or a multiple of 2. Okay, so let's do this the other way. Let's do this as the fifth root of 32 to the 6th. Okay, and this might get pretty big. So 32 raised to the 6th. Let's even see if the calculator can handle it. Wow. Okay, so that's okay. It's pretty big, but it's still fitting on my calculator. And now I can take that to the 1/5 power, and I get back to 64. Okay, and when you think about it, that makes sense, because it's 6 over 5, right? So it's basically going to come out to taking the fifth root of it, but then doing an exponent, right? Multiplying it by itself 6 times. So if the fifth root of 32 is 2, it's the same as multiplying 32 by 2, because I have one more in my numerator.